Hey, pre-algebra, we are covering CO48, identifying a function, giving a graph or relation. We just reminded ourselves what a relation is. You're going to interrupt your class, though. See if I have one for you. We just remind ourselves what a relation is. A relation is a collection of ordered pairs, okay? And that could be a table, better than you had. That can be a table, that can be a segment, that can be a line, but it's basically just any collection of ordered pairs. But we're going to get a little more specific today and talk about functions, okay? And so the definition of a function, it is a relation where every x value has exactly one corresponding y value. Okay? A function is a relation where every x value has exactly one corresponding y value. A relation where every x value has exactly one corresponding y value. Okay, so let's take a look at what I mean, right? These three relations here, I've identified for you as functions. And what you want to look for here is as you look down the x values of the table, when x is 2, what is y? 9. When x is 5, what is y?
7.
When x is 8, what is y?
10.
When x is 4, what is
18.
18. Okay? Another example here. X is 1, y is?
1. 6.
6. X is 8, y is?
7.
X is 9, y is?
10.
X is 12, y is?
15. 36.
Okay? Please don't just say silly things. Right? Now we'll go over here into things that are not functions. What's the difference between this table here and the two tables that we just went through over here? What do you notice is different? Anything stand out to you? Shay?
There's negatives.
Negatives. Okay, good. I really don't want to have to stop class to tell you to not talk. That should be a given. Okay, thank you. Kylie.
The functions are like straight and the not functions are like curvy.
Okay, but you can't really tell if it's straight or curved by looking at the table necessarily. We'll get to the graphs in just a little bit, but what do you notice about the table that's different? Anything stand out to you other than Shay said there are negatives? What else? Kate?
That's always a big.
Yes. In this table, there's an x value that repeats itself. Okay? So let's go back to our definition. It says a relation where every x value has exactly one corresponding y. I went through each of these x values in these function tables, and every y value was different for that given x. But here, if I said, what's y when x is -2, you've got two different things to say. When x is -2, y is both 7, and y is 10. That's what makes it not a function. X doesn't have exactly one corresponding y. It has two of them. Okay? When x is -2, y is two different things. Therefore, it's not a function. And that is different than what we have here. You might be thinking to yourself, well, wait a minute now. Y repeats there. That's okay. Because for the x value of 8, there's only one y value, 10. For the x value of 9, there's only one y value, 10. Even though those y values are the same, it's only one for each of the different x's. So it all goes back to the x's. Okay? This is an analogy that may help you. You can relate it to birthdays. Can two different people have a birthday on the same day?
Yeah.
Yes. Think of this 8 as being one person, this 9 being a different person. They can both have a birthday on the same day. That's okay. Right? On the other hand, can the same person have a birthday on two different days?
No.
No. Not a function. So as long as x repeats itself, as we see it does also here, the same person has a birthday on 3 different days? No, not a function. If x doesn't repeat itself, everyone's got just one birthday, we're all good. Even if 2 different people have the same birthday, still okay, still a function. Isn't that brilliant? I thought of that myself. Is that good?
Yeah, it was good.
Thanks. Okay. Kylie brought up another part here. She brought up the graphs here. She said that in this function graph, everything's kind of straight. In the non-function graph, it's curved. Not so much to do with that per se, but what this is called, we can tell if a graph is a function by using the vertical line test. I think I defined this a little bit further down the page too. Maybe not. But the vertical line test. If I draw a vertical line through this graph, how many times does each line touch the graph? Only once, right? Each line only touches the graph in one place. This line touches it there, this line touches it there, 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 there. Each line only touches the graph in one spot. However, what's going to happen if I draw a vertical line through that one over there? Jack?
It'll touch the little previous line 2 times.
It touches the graph in 2 places. What that means is that for this x value here at 2, y is 2 different things. Here's the ordered pair 2, 2, approximately. Here's the ordered pair 2, -2. Right? When x is 2, y is 2 different things. The same person has 2 different birthdays. No, not a function. So for a table, you're just looking at, does x repeat? If it doesn't, function. If it does, not a function. For a graph, you can use the vertical line test. How many times does any vertical line touch the graph? Only in one spot, function. More than one spot, not a function. Okay? Questions so far? Abby.
So, like, let's say, you had 1 in your x value, and you had 1 in your y value, would that be a function?
That's okay. Yep, as long as x doesn't repeat itself. I think what Abby's asking is if you've got a 1 and a 1, one that's an x and 1 that's a y, as long as there are no other x values of 1 in the relation, it'll be a function. Okay? It really has nothing to do with the y column at all, only the x column. Jack?
Can I write for here if it's a function?
What are you looking at? Sorry.
Oh, the pencil area.
You moved on. Okay, before we move on, any more questions on what we have shown? Because once I delete the ink and move on, and get it back. Okay, moving on. Jack, go ahead.
So for the functions, can I just write fun, and for the non-functions, can I write sad?
Not fun, sad.
Sad.
As long as it's clear to you when you look back on this, prepare for the test, what fun and sad means, then yes. This is kind of your own work. Which of the following are functions? Explain how you know. The first one, -1, 0, 1, and 5 for the x, 5, 5, 5, and 1 for the y. Raise your hand if you say, yay, function. Raise your hand if you say, nay, not function. The yay functions are correct.
Oh.
Why? Those that raised their hand said yes. Why? John?
Because -1 is not the same as 1.
Right. -1 and 1 are different values, meaning they're different people, right? So even though y repeats, we don't really care about this column at all. We can ignore it completely. When it comes to functions, we're looking at, does x repeat? And since it does not repeat, it is a function. Next one, raise your hand. Yay, function. Nay, not a function. Ooh, overwhelmingly nay. You are correct.
Yeah.
Okay? The same person can't have 4 different birthdays. That doesn't happen. Right? X repeats itself throughout, so it is not a function. Not a function. Last one. Yay function? Nay not a function? Yay function. Okay? Because if we ignore that y column, which we can do, nothing about the y column matters here. Does x repeat itself? It does not. 4 different x values, therefore it is a function. Okay? Therefore it is a function. The word problems here says 3 ordered pairs of a relation are 4, 8, -3, 6, and 5, 10. So if you want to draw these out in a function table, 4, 8, -3, 6, 5, 10. That's how we will look. Okay? Our x values 4, -3, and 5. Our y values 8, 6, 10. It says, now write a 4th ordered pair that will make the relation not a function. Right now it is a function because x doesn't repeat. Those are all different x's. We want to add an ordered pair to this that will then make the relation not a function. Give me an answer, Abby.
4 and 18.
4, 18. If we add that ordered pair, it would make it not a function. Why? Because now the 4 repeats itself. Okay? John.
I said 4, -8.
4, -8 would make it not a function. Haley. -3, 7 would make it not a function. Right? Camille.
5, 12.
5, 12 would make it not a function. Any ordered pair that has either a 4, a -3, or a 5 as an x value would make it not a function. Because now you've repeated an x. Okay? You repeated an x. Yes?
For the next one, I think one you should remove to make it a function is -2 and 5. Negative.
Well, let me read the question first, then we'll see where we're at. It says 4 ordered pairs of a relation, Quentin, turn around please, are 0, 6, -2, -5, 3, -5, and -2, 4. Which ordered pair should be removed to make the relation not a function? Johnny said he wanted to remove -2, -5. Do we agree? Do we have a secondary answer? Camille? You would either, or you could also remove -2, 4. You wouldn't have to do them both, but just remove one of them, right? Because if we remove one of them, now we only have one x value of -2, which would make this a function. Okay. Last one. A game show has you randomly select a number that corresponds to a prize. If you select 4, you get a puppy. If you select 7, you get a scooter. If you select 11, you can choose between a taco and a trip to Hawaii. Obvious choice.
Taco.
Yes. Does this situation represent a function? Why or why not?
Can we do both?
Okay. Does this situation represent a function? Why or why not? Go ahead and think about it. Jot down your own answer. Okay. You pick a number, you get a prize. A 4 gets you a puppy. A 7 gets you a scooter. And 11 gives you a choice. Does that represent a function? Yay or nay?
Wouldn't you want the trip to Hawaii so you can sell the tickets and then get more tacos?
Instant gratification. I want my taco now, Jack.
I say yes because
Hawaii will still be there in a month. That taco will be moldy.
I say yes because
I didn't ask. Yeah,
Oh.
No, I'm not asking for answers yet. I want you to think about it. Is this a function? Okay. Who would like to share their thoughts? Function or not? John, go ahead.
yes,
Why?
because all the options sound super fun.
Do they sound super fun? Okay. Wyatt?
Oh no, because you have to have 2 11s because there's 2 choices.
Okay. So 1 vote for yes, 1 vote for no. Camille, what do you think?
No, because for 11, there's like 2. You can't have like 2 choices because I'm pretty sure that would be like the y value.
Okay, good. Jack?
No, because there's 2 choices. You still choose.
Okay, Kate?
No, because that's
It seems to be pretty overwhelming no. Let's just make a function table here. Okay. When x is 4, we get a puppy. Do puppies have tails? Yeah, they have tails. There we go. All right. When x is 7, you get a scooter.
It looks like it's more like
Right? When x is 11, you could either choose a taco or you can choose a trip to Hawaii. That's a palm tree, by the way, in case you're not sure what that picture is. Looks like a sad face in the middle there.
Looks like a dandelion.
So, function is not a function because for that choice of 11, that x value of 11, there are 2 possible y results. Okay? 2 possible, so not a function. No. And the reason is because that x repeats. Okay? Questions, comments, concerns, complaints, comments, congratulations, criticisms on CO48.
Congratulations!
Thank you, John. No homework tonight. That is how you math.
Don't forget to like and subscribe.